Good morning, students. Good morning.
Good morning, sir.
Yeah. So I think what the questions we have given on last class, I think I asked her to solve 2-3 questions. No? Which questions we have given? So have you tried that questions?
Sir, question number 3, 4, 5.
Yeah. So not tried, tried. So if not, no problem. Try it today. Okay. So then we can go for question number 6 onwards. Let us complete this. Still not getting. Let us see in tomorrow's class those questions 3, 4, 5. Okay. Okay, guys.
Yes, sir.
Yeah. So go to the question number 6 once, please. Students, all of you. Question number 6. Page number. I think 8 to 20. I think this is the old one. You may have the new book. Okay, so this is the old book. The last year version might be page numbers are a bit different.
Sir, we also have the same book.
Same book, sir.
Yeah, so then page number 821. Page number 821. So sixth one, let us see then. Okay, so 3, 4, 5 we have given to you for practice. If not, then you can try it at least today. So sixth one, see that question number 6. As the temperature increases by 10 degrees centigrade, the length of the pendulum clock increases by 0.01%. Hence, they have given that the percentage of change in length they have given. The loss of time that pendulum, the loss of time that pendulum. So, students just have a look on that problem carefully. What they have given that change in length they have given that. Change in length means delta L by L, that's equals to, they have given 0.001%. 0.001%. This can be written as delta L by L is equals to 0.001 divided by 100, I can write. So then finally what we can write? Delta L by L is equals to delta L by L equal to, I can write 10 to the power of minus 5. Delta L by L can be written as 10 to the power of minus 5. And change in temperature delta theta equals to, they have given that 10 degrees. Delta theta equals to 10 degrees centigrade. So then what they asked, time lost or time gained per day. I think at last we have given one note. No? Time lost or time gained by the pendulum per day. What is that formula? Delta T is equals to half alpha delta theta into 86,400 seconds. 86,400. Sixth question. Which we have? No. Question number 6. If you want, we can read the question. Okay, so then they have, I think this is the formula, question number 6. So just let them go through the question number 6 now. Just wait. Sixth question. 3, 4, 5 we have asked them to solve. Sixth question. So that's so that they, so they have given this is the percentage change in length they have given for a temperature difference of 10 degrees centigrade, then what is the time lost time gain? So then the time loss delta T equals to half alpha delta theta into 86,400 seconds. To use this formula, delta theta value is 10 degrees centigrade and alpha value. So we don't know alpha value. How to calculate alpha means have a look at this. We know that alpha is equals to delta L by L into delta theta. Okay, so then this alpha value, if I substitute this, so then change in time delta T, that's equals to half into delta L by delta alpha means I can write delta L divided by L to delta theta into delta theta into 86,400 seconds. So this delta theta gets cancelled. So then we can write delta T, that's equals to half into, okay. So then delta L by L means already we got 10 to the power of minus 5 into 86,400. Just if you calculate this, then you will get the time lost by the pendulum per day. So we can make that 8.64 into 10. No problem. Okay, got it, students? Just what they have given, this is the data they have given. They asked you to calculate delta T is equal. Delta T means time lost. Delta T. This we need to calculate. Time lost by the pendulum per day is already we have discussed that. Half alpha delta theta into 86,400 seconds. Per day it is 86,400. So, but this alpha value we don't know. But alpha value definition can be written as alpha equals to the fractional change in length per degree rise of temperature. Delta L by L upon delta theta. Substitute that delta theta gets cancelled, and then you will get delta. So, have you got the answer according to the key? Check it once, students.
Correct, sir. 0.432.
Yes, sir. 0.432.
Yeah. So right, go to the next question then. 7th question after this. Copy it now, students. So done. So just to have a look on that question number 7, what they have given first. Identify the question number 7. Okay, so then after that we go for question number 7. What they have given question number 7. So a steel wire of cross-sectional area. Steel wire they have given cross-sectional area A is equals to 0.6 millimeter square. So then 0.6 millimeter square mean I can write 0.6 into 10 power minus 6 meter square. It can be converted into millimeter square from meter square. So it is held between the two fixed supports if the tension in the wire is negligible initially and just taut at the temperature at 20 degrees centigrade. Determine the tension when the temperature is falls to. Determine the tension. The temperature is falls to 0 degrees centigrade. So they have given the Young's modulus of the steel. So they have given the value of Y is equals to 2.1 into 10 to the power of 11 Newton per meter square, and alpha value for steel they have given that 12 into 10 to the power of minus 6 per degree centigrade. They are asked that P is equal to how much? P in the sense not time. Tension. Okay, so tension is what? Tension is a kind of force. Tension is a kind of force. Understand the problem first. Steel wire of area of cross section 0.6 millimeter square is clamped between the two rigid supports at 20 degrees centigrade. So at theta 1 is equals to 20 degrees centigrade. When the temperature is drops to 0 degrees centigrade, what is the tension in the wire which is developed? So they have given Young's modulus of the material and the coefficient of linear expansion of the material. They have given that. So therefore, from this, what we can write from this? So thermal stress formula is equals to what can I write? So therefore, thermal stress F by A is equals to Y alpha into delta theta omega. Y alpha into delta theta thermal stress. So what is this? F stands for the force acting per unit area in the rigid bar due to the temperature difference, that is known as the stress. So if this A is taken this side, so then F is nothing but Ya alpha delta theta. What is this? F means force generated inside the spring or rod due to the change in temperature. That force is nothing but tension in the rod. So therefore, the tension T equals what can I write? The tension T is equals to Ya alpha delta theta. So then that implies Y value substitute that 2.1 into 10 to the power of 11. Area cross section is 0.6 millimeter square. Then I can write 0.6 into 10 power minus 6. Okay, Y alpha value is 12 into 10 to the power of minus 6. And delta theta is equals to what can I write? So your changing temperature is 20, so 20 degrees. It's okay. So force will never be negative, magnitude of the force. Okay, so here the temperature of the rod is decreased, it means that is the compressive force. So if the temperature of the rod is increased, it means that is the elongated force. Okay, so just like a string length is try to reduces because of that internally compressive force will be act on the string. That compressive force they are asking. Okay, so if you take the negative or positive, the magnitude of the force will never change. So therefore, anyway, we know that from the data of the problem, it is a compressive force. That's why no need to take the negative. To calculate the magnitude of the force, I can write it into delta theta means temperature difference that is equals to 20 degree centigrade. So if we calculated that value, then we will get the answers. So I can write tension T equals to 2.1, 0.6 into 12 into 20. Here 10 power 11, here 10 power minus 6, here 10 power minus 6 means then we will get
10 power
10 power minus 1.
10
So
power minus 1.
10 power minus 1, 0 gets cancelled, then T is equal to calculate this value. So 2.1 into 0.6 into 2 means 1.2 into 12 I can write it. So from there onwards you can calculate the tension. Have you got the answer?
Yes, sir. 30.24.
Students, one important point is sometimes we need to measure the temperature difference is negative. Sometimes we may need not to that. Identify that when we have to consider the change in temperature delta theta is negative, when we have to take the magnitude of the force means here if the temperature is increased, it means the same force can be called as an elongated force. If the temperature is decreases, means the same force we can call it as a compressive force. The force nature is same, only the acting directions will be different. Elongated force means it will exert a repulsive force on the wall. Compressive force means it will exert a drag force on the wall. So that's why here in these cases, if we consider negative and positive also, force value does not change. From the data of the question, as the temperature is decreases means in the rod there exists a compressive force will be there. Everyone can notice that. When we can take the delta theta as negative means in some cases, for example, expansion of the measuring tapes are there. On such case, delta theta positive means you should take positive, delta theta negative means you should take negative. Why? What is the reason? Means length is increases when temperature is increases, length is decreases when the temperature is decreases. We need to know about how much amount of the magnitude either may be increased or decreased, and there we need to consider the negative values. Okay. So that's because of that cases I identify that when in some cases we may not bother about the sign of the delta theta. Some cases it is required. So here the magnitude of the force is compressive. Already we know that from the everyone it is clear that when the temperature decreases, it is a compressive force. What is the magnitude of the compressive force? That can be identified by this formula. I'm anyway confined about the magnitude, that's why I will focus on the magnitude of the temperature difference. I will never bother about the sign of the temperature, whether it is positive or negative, doesn't okay, not at all here. It doesn't have any importance. In some problems, we need to give the importance as well. Okay, so then when we need to give the importance, that depend upon the data application. Okay, so with what data they have given, that will depend. Got it? Students,
Yes, sir.
have you got the answer for this?
Yes, sir. 30.24.
Check it with check it with the key. Check it with the key. The key is exactly
Correct, sir.
yeah. Fine. Next question. Similarly, next eighth, ninth, let us see. Then after that, 10th, some problems you will try it. So then 4 to 5 problems we'll discuss now. Okay. Eighth question. After this, see that question number 8. What they have given. An iron rod of length 50 centimeter is joined to an aluminum rod of length 100 centimeter. All the measurements refers to 20 degrees centigrade. If the coefficient of linear expansion of aluminum is 12 degree, 12 into 10 power minus 6, and that of iron is 24 into 10 power minus 6, the average linear expansion coefficients of the composite system. So, what is this problem means? Just we will try to derive one formula, then we can substitute those values. So, look at here. These are the two rods are joined. Okay, two rods are joined. So, let L1 is the length whose coefficient of linear expansion is alpha, and this is another rod. This is another rod whose length is L2 and coefficient of linear expansion is alpha. These two ends are joined together. So then what is an average coefficient of linear expansion means we'd like to find the equivalent linear expansion coefficients we have to calculate. Equivalent in the sense you may lower classes you may have studied that two resistors are connected in series. What will be the equivalent resistance? In a similar manner, two rods are divided like this. Then what is an equivalent coefficient of linear expansion? So like this is compared with an equivalent rod. Okay, so this is an equivalent rod whose length is I can write L equivalent and alpha equivalent. So what it means by this is an equivalent rod means this rod can replace these two. This rod can replace these two means how this rod can be replaced by these two means for a delta theta range of temperature difference. Okay, so for example, if 100 degrees temperature is raised, let us say for an example, these two rods together expand how much amount? The single rod will expand the same thing. Okay. So, for example, here 100 degrees temperature is raised. This rod is expanded by 1 millimeter. This rod is expanded by 1.5 millimeter. Then what is an expansion in this combination means 1 plus 1.5, 2.5 millimeter. So this 2.5 millimeter will be expanded by this equivalent rod by the same rise of temperature. So that is meaning of the equivalent rod. So this plays the same role as the role played by the combined these two rods. That's why we can replace this combination with this single rod whose length is L equivalent. L equivalent means equivalent length. Alpha equivalent means equivalent coefficient of linear expansion. So therefore, delta 1 is the changing length of the first rod. Okay, delta 1 is the changing length of the first rod. For delta theta rising temperature. Okay, so then if delta theta is raised in temperature, so we notice that delta L1 is elongation in the first rod. Similarly, delta L2 is an elongation in the second rod. So then what we write delta L1 means delta L1 that's equals to L1 alpha 1 into delta theta. Similarly, delta L2 that's equals to L2 alpha 2 into delta theta. So then what is the net elongation produced in this composite bar means net elongation is nothing but delta L1 plus delta L2. Then I can write L1 alpha 1 delta theta plus L2 alpha 2 delta theta. So this is the net elongation. Okay, net elongation delta L1 plus delta L2. L1 alpha delta theta, L2 alpha to delta theta. So then what is an equivalent means delta L equivalent that's equals to L equivalent into alpha equivalent into delta theta. So therefore this rod replaces this combination means here together this rod will expand and how much the single rod will expand the same thing. Then according to that, the equivalent expansion delta L equivalent that's equals to delta L1 plus delta L2. So that implies L equivalent alpha equivalent into delta theta is equals to here delta theta is common. Then I can write L1 alpha 1 plus L2 alpha 2 into delta theta. This delta theta gets cancelled. So then alpha equivalent is equals to L1 alpha 1 plus L2 alpha 2 divided by L equivalent. What is an equivalent length means equivalent length must be sum of these two lengths L1 and L2. So then I can write L equivalent is equals to L1 plus L2. Substitute that value alpha equivalent is equals to L1 alpha 1 plus L2 alpha 2 divided by L1 plus L2 we can write. So this is the formula to calculate the equivalent coefficient of linear expansion. Here L1 alpha stands for first rod, L2 alpha stands for second rod. In the problem they have given two rod lengths given and coefficient of linear expansion is also given. Just to substitute this L1 alpha, L2 alpha values and then you can get a alpha equivalent. So this is an equivalent rod. And what is, how can I say that this equivalent rod means this rod will elongate the same as these two rods are elongated in combined. So for example here delta 1 is elongation produced for the first rod and delta 2 is an elongation produced in second rod. What is the net elongation produced on this composite bar means delta L1 plus delta L2. The single rod will expand the same as these two rods are elongated for the same temperature rise. So then what is an equivalent length means the equivalent length must be sum of these two lengths L1 and L2. So according to that we have derived the formula. Got it? Got it, students?
Yes.
So just a substitute, you'll get the answer. Alpha equivalent coefficient of linear expansion. Sir, units they have given in centimeter. Convert it now. Units, no. Here,
The third option.
yeah. Keep the same units because the numerator is also length is there, denominator is also length is there. Centimeter get cancelled. So in what units alpha and alpha, we will get the same unit for alpha equivalent also. No need to bother about the lengths. Yeah. Okay, na? Completed, students?
Yes.
We'll go to the next ninth question. See that question number 9, what they have given. So there is a graph they have given. Observe carefully the graph is the variation of the length of the two metals A and B with the change in temperature as shown in the figure. Coefficient of linear expansion of the material alpha A for metal A and alpha B, they have given the values. Okay, they ask her to calculate what is alpha A and what is alpha B. What is an initial length of A? Amma? Any students observe the graph? What is an initial length of A? 1000 millimeter. No? Initial length of A is 1000 millimeter. And what is an initial length of B is 1002 millimeter. So hence, once you can observe that what is the change in length of A means for T temperature difference, the length is increased from 1000 to 1006 millimeter. So then the change in length across the metal A is 6 millimeter. The change in length of the metal B is increased from 2 to 1002 to 1004 millimeter. The change in length for the metal B is 2 millimeter. So they ask her to calculate first for metal A. First, this is the metal A, and this is the metal B. What is an initial length for metal A means 1000 millimeter. Let it be no problem. Next, the changing length of delta A that is equals to, we can write 6 millimeter. How I am writing 6 means final length is 1006 millimeter, initial length is 1000 millimeter, then changing length is final length minus initial length. What is the change in temperature means delta theta of A is equal to some T degree. Similarly, for metal B, what is the initial length for metal B? 1002 millimeter, and delta L of B that's equals to 2 millimeter, and delta theta for B that is also T degree temperature. Both are for same range of temperature. And here alpha A is equal to, we don't know, and alpha B value we have to calculate. What is an alpha B value they have given? 9 into 10 power minus 6 okay, per degree centigrade. So this is about the data they have given from the graph. Once you can observe the graph, it will be clear. So there are the variation of the two lengths of the metal A and metal B for the few degrees range change in temperature. From the graph, it is clear. This is the data. This is the data. So then, what is the change in length? I can write observe it clearly. Delta L of A that's equals to LA alpha A into delta theta of A. Delta L of B is equals to LB alpha B into delta theta. Is this clear no formula? This is our equation number 1 and this will be our equation number 2. So then divide equation number 1 with 2 means I can write delta L of A divided by delta L of B is equals to LA alpha A into delta theta A divided by LB alpha B of delta theta B. So as the temperature difference is same for both groups, so then I get this gets cancelled. Delta L A means I can write this is 6 millimeter, 6 divided by 2. Anyway, millimeter gets cancelled. That's equals to L A means length of A is 1000 millimeter into alpha A I don't know. So LB means length of B is 1002 millimeter, 1002 millimeter. Here also millimeter gets cancelled. That's why I didn't convert. And alpha B value they have given that 9 into 10 to the power of minus 6. So here in this expression everything is known except alpha A. That alpha A can be calculated. So then alpha A is equals to here alpha A equal to I can write this entire denominator is taken to numerator. 6 by 2 means I can write 3 into 1002 into 9 into 10 to the power of minus 6 divided by 1000. So check it. This is alpha A, then we can get alpha. Check it once. Students got it? How we have done this problem? Online students. Got the answer? Alpha A.
1 minute, sir.
Got it, Emma?
1 minute, sir. I'm sorry.
Good. Done.
Sir, 27.
Option is there. Yeah, 27.
27.054 becomes
Yes, sir. 27.054.
0.54 into 10 power minus 6 per degree centigrade. So T value how to calculate means substitute that alpha A value here. So therefore from equation 1 delta LA means I can write this is 6 is equals to LA means 1000, okay, into alpha A means alpha A is 27 or into 10 power, let it be no problem, we'll get approximate answer. 27 10 power minus 6 into delta theta is nothing but T. So then T is equal to 6 divided by 1000 into 10 power minus 6 means I can write 27 into 10 power 3. So that implies T is equal to 6 into 10 cube divided by 27 degrees centigrade. So then we calculate the T value 6000 divided by 27. How much nearly? Is there an option?
22.22, sir.
Check the options once.
Fourth option, sir.
220.
222.22, sir.
Yeah. Correct. That is students. 222.22. Then 222.22 degrees. So like this we can calculate the value of this is question is advanced question once upon a time in the sense just at least some 4 to 5 years back. The same graph question is given for I think it is one of the passage question. Okay, exactly I didn't remember, but we have noticed this question 4 years, 5 years back in the advanced paper. So got it this question? Come on, students.
Yes, sir.
So just it is clear from the graph we have written the data and then we have applied this. So next question 9th after that let me do 10th, 11th and 14th, yeah, bimetallic strip. So with that this will be completed. So let me go to the 10th. Question number 10 after this. What they are given question number 10. Two metal rods are fixed end to end between the two rigid supports as shown in the figure. Each rod of length L and area of cross section A. When the system is heated up, determine the condition when the junction between the two does not shift. So they have given this is the question like this. This is the two rods. Okay, so this is the two rods of equal length. This will be L. This will be also L. This is Y1 alpha 1. This is Y2 alpha. So this is the case. What they have given means under any change of temperature, this junction should not displace. So let us check the possibilities when this junction will displace. For example, this is a marked rod 1, this is a marked rod 2. If the rod 1 is expanded more than rod 2 means then what will happen? It will offer more force on the second rod. That's why the second rod will be compressed and the first rod will be elongated. So generally, if the temperature is increases, what will be happen? So if the length of each rod is quite increases, but here it is no chance of re-expansion. Then this rod and this rod both will exert the force on rigid support as well as arm junction also. This rod will exert some force on the rigid support and junction also similarly this also. So for example, if the first rod is exert more force means then what will happen? So the length of the first rod will increases and the length of the second rod will decreases. The junction will be displaces towards right. Okay. For example, if the second rod exerts more force than compared to the first rod means then on such case what will happen here? Second rod will be elongated and first rod will be compressed and this junction will be displaced towards left. So the junction will be displaced depending upon the force that will be generated inside the rod. If the much force is generated due to the change in temperature in the first rod, then length of the first rod is increases, the length of the second rod will get decreases, and the junction will be displaces towards right. Similarly, if the much force is generated in the second rod, the much force is generated in the second rod. When compared to the first one, then the second rod will be elongated and first rod will be compressed so that the displacement will be junction will be displaces towards left. So then the two equal and opposite. So here the force generated in the first rod is same as the force generated in the second rod. Then on such case, these two rods exert equal and opposite forces. That's why there will be no displacement of the junction. Hence, then this junction should not be displaces means on such case what we can write. So let F1 is the force exerted by the first rod. F12, I can take F12, and here it is F21. F12 stands for what? Force on the second rod. This is F21. I can write F12. So this is the F21 means force on the second rod due to the first one. And F12 stands for force on the first rod due to the second one. If this F21 is more means junction will be displaces towards right. If F1 is more means this junction will be displaces towards left. If these two are equal means this force cancelled out by this one and this force cancelled by this one, there will be no displacement of the junction. So therefore I can write when F12 that's equals to F21, the junction does not displaced. Okay. Then thermal stress is equal to what is the formula? Thermal stress F by A is equals to Y alpha into delta theta. So from this relation, F is equal to what can I write? Y A alpha into delta theta. This is the force generated in the rod due to the change in temperature. So then I can write F12 means what? F12 is the force on first rod due to the second means the force which was generated in the second rod. Then I can write second rod is having x modulus y2, linear coefficient of expansion alpha 2. From the graph, it is clear that area of both the rods are same. Let it be A, and temperature difference of both the rods is also same. Delta theta. Similarly, F21 means force on second rod due to the first one. So force on second rod means that will be generated in the first rod and acted on the second rod. Force generated in the first rod is F21 means I can write according to this formula Y1 alpha 1 A okay into delta theta. As this according to argument, when these two forces are equal and opposite, then the junction does not displace. So therefore, F12 that is equals to F21. So that implies F12 means I can write or else Y1 alpha 1 A into delta theta that's equals to Y2 alpha 2 A of delta theta. This one gets cancelled. Finally, we can get Y1 alpha 1 is equals to Y2 alpha. This is about the condition when the displacement should not be, the junction should not be displaced. Okay, so let me write a little bit. Okay, so this one. F1 to F21. So is there any confusion regarding this terminology F1 to F21? F12 stands for force on first rod due to the second one. F21 stands for force on the second rod due to the first one. That's it. If you want, you can write there F12 stands for what F21 stands for. If you can remember, no need to write. That's your wish. Okay. So students got it. This one online students.
Yes, sir.
Okay. So then this condition the rod will get never displaced. Measuring tape formula we have given. What is that? Reading.
Sir, reading into 1 plus alpha s delta theta.
If both are expanded, also we have given. No? Alpha of scale minus alpha of object. No? 1 plus. So 1 plus alpha scale theta minus theta 2 minus theta. If both are expanded, only scale not object also expanded. One note I have given, I think. Okay. So, R into 1 plus alpha is minus alpha. Alpha object, yes, right. The same formula which we are going to use there to solve the problem number 11. Those who are completed, go to the problem number 11. Steel rod at completed. Okay, so let me read this problem and I'll give the book to you. So 11th one, steel rod at 30 degrees centigrade is observed to be 1 meter long when measured by a brass scale which is correct at 0 degrees centigrade. The correct length of the steel at 0 degrees centigrade is So here the brass will show the correct time at 0 degrees centigrade, but the brass scale was used at 30 degrees centigrade, then it will show definitely it will not the true length. So then what is the true length means already we have given a formula. True length that is equals to L equal reading of 1 plus. So true length or actual length. True length L is equals to I can write reading of 1 plus alpha of scale minus alpha of object into delta theta. So this one only we have already derived this formula. So then here it is observe this one. Observed to be 1 meter means reading value that is equals to 1 meter. The measurement made at 30 degrees centigrade, but the temp actually that is okay. Actually, that is we can write still we can write this formula. Read length L is equals to reading of 1 plus alpha s minus alpha object into theta 2 minus theta 1. Okay. So therefore, reading that is equals to reading can be equal to 1 meter. Observed to be means reading that is 1 meter. Initial temperature theta 1 equals to 30 degrees and final temperature theta 2 is equals to 0 degrees. Alpha of the scale is made up of brass. No? Brass only no. So what is alpha value for brass? 19 into 10 to the power of minus 6. Object is made up of steel. Yeah. Now what is alpha value? Scale. S stands for scale. O stands for object, irrespective of any material. Okay. Now 12 into 10 power minus 6 per degree centigrade. Here also per degree centigrade. So then substitute that value here. True length L is equals to reading means 1 into 1 plus alpha of scale minus scale is this one. So therefore 19 minus 12 into 10 to the power of minus 6 into temperature difference theta 2 means 0 minus theta 1 means 30 degrees. Okay. So therefore L is equals to 1 of 1 plus 19 minus 12 means 7 into 10 power minus 6 into 30, okay, minus 30. Then you can calculate this value, then you will get the answer. Calculate the value. Here temperature is dropped, no? That's why I have taken minus. Make it fast, only 5 minutes left. We need to solve the last problem also.
Sir, minus 1.00021.
Minus, no, ma.
Yes, sir, you have given minus now, sir.
Here it is 1 minus of this means less than 1 only you will get. No? Is there
Yes,
no?
sir.
For options, it is given 1.0021, sir.
But you got the value?
Same value with minus, sir.
Sir, in a solution, they have taken plus 30, sir. They have not taken minus 30.
Minus only, that is. Steel rod at 30 degrees centigrade is observed to be 1 meter long. Okay, the brass is scaled. Yes. Okay, here, so why it is means plus only, I'll tell you. Actually, brass scale was give the correct measurement at 0 degrees centigrade, no? Students?
Yes.
It is measured the value at 30 degrees centigrade means temperature has raised or what? Raised, no? Understand this problem. 0 degrees centigrade is the calibrated temperature, reference temperature. But the measurement is made at 30 degrees centigrade means temperature difference is made positive or temperature difference is made negative. Increases, no, temperature is.
Yes, sir.
Yes.
Understand this problem, okay? But instead of taking the 30 first, the 0 first, we have considered the 30. That's the problem we got it. So that is here it is. Okay, so delta theta is equals to, we can write where it is. Yes, finally we can write this is delta theta, that's equals to, we can write plus 30 degrees. No problem. So when we can take negative means if the measurement is made less than 0 degrees centigrade means there you can take the negative value. But here measure scale was calibrated at 0 degrees centigrade and the scale was measured at the temperature of 30 degrees means temperature is increased, that's why if you take plus. Understand that problem? So to confuse the student, they have given they have volta they have given the 30 degrees centigrade it is measured and it will give the correct reading at 0 degrees centigrade means If the same question is read like this, okay, so see clearly the same question. A brass scale which is correct at 0 degrees centigrade, okay, which measures a steel rod of length 30 degrees centigrade observed to be 1 meter means, if I read the question like this, is the temperature is increased or decreased?
Increased.
Increased, no? So that's
Increased.
the, yeah. So that's the reason. Okay, that's the reason. So initially theta 1 to theta 2 means calibrated temperatures. Then I can write theta 1 is equals to 0 degrees centigrade at which the scale is calibrated. Theta 2 is nothing but 30 degrees centigrade. Okay. So if theta 2 value is less than 0 degrees centigrade means on such case it will become negative. Understand the problem? A scale which gives the correct measurement at 0 degrees centigrade, which is used to operate at 30 degrees centigrade means temperature is increased. That's why we should take plus only here. Okay, so at 30 degrees centigrade, 30 degrees centigrade, then we can get the answer that is. While reading the question, so I also didn't observe clearly the question is. Now got the question, students? Understand the question, please. Is there any doubt you can ask?
No doubt.
Yeah, ask. Question number 11 regarding that. Any doubts you can ask other students, please.
No doubt, sir.
Yeah, so, but actually they have given a question is bit reversed. The same question, if you read like this, then it will be clear. So once again, I am reading the question. Just have a look on it. A brass scale which correct at 0 degrees centigrade, which is used at 30 degrees centigrade to measure the steel rod length observed to be 1 meter long. Then what is the true length means? Initially at 0 degrees centigrade, it will give the correct reading. It is operated at 30 degrees centigrade. No, it is operated at 30 degrees centigrade. That's why temperature here is increased. Then you should take negative means if it is operated less than 0 degrees centigrade means then you can take the temperature, fall in temperature. Okay. So right, 14th one, let us see 14th one. Then after this, I got the answer for this. Got it? Emma, online students, what is the value of L? 1 point
1.000.
00021.
21 meter. That's it. Huh? 21 meter, right? So this is about the problem. Okay. Next, last one, see that last question. A bimetallic strip of thickness 2 centimeter. So this is a bimetallic strip, you can see. Okay. So here you bimetallic strip means already we noticed that two different materials of equal length is divided together. Okay, divided together. The thickness they have given, let it be t. Okay, small t. Small t is equals to, we can write 2 centimeter. 2 centimeter.
Sir, it's not visible, sir.
Okay, so it is 2 centimeter thickness is equals to. So one is made up of with two different materials, silver and zinc. So then I can write silver value is more or zinc value is more. Zinc is more, no? That's why zinc will expand more than silver means here it is zinc. I can write alpha 1. Here it is silver alpha 2. Initially, at small L is the length. On heating, what will happen means on heating, zinc will expand more and silver will expand less when compared to. What I am saying means alpha value for zinc is more than silver. That's why the expansion produced in zinc will be more than that of the silver for same rise of temperature across both the materials. Then we will get the shape like this. This will be the shape. Okay. this one. Okay, this is nothing but alpha 1, this is alpha 2. Understand this is, on heating it will be get like this. So let us take the length of this, you can take it as L1 and you can take it as L2. So then this L2 is final length of this first dot whose linear coefficient of expansion is alpha. This L1 is the final length of this. Then L2 can be written as what term? L2 that's equals to L into 1 plus alpha 1 into delta theta. Can I write like this? Final length equals to initial length into 1 plus alpha delta theta according to that diagram. Similarly, L1 is equal, L1 is the final length of the silver rod. That's equals to initial length of the silver rod is let it be L of 1 plus alpha 2 into delta theta. So let I can write this is I can write R1 radius of curvature and just a second. Okay, so this I can write R2. So let making an angle theta. I can write theta. Understand this? From this one, what can I write? From this circle, I can write angle theta equal what can I write? Angle theta equals to length of the arc by radius. So length of this arc is nothing but what? L1 divided by R1. So then I can write L1 is equals to theta into R1. Similarly, from this triangle, angle theta equal to length of this arc is nothing but L2. Then I can write theta equal to again L2 by R2. So then I can write L2 that's equals to R into theta. But L1 value I got this thing and L2 value I got this. Then I can substitute the value. L1 is equals to what can I write? Theta into R1 that's equals to L into 1 plus alpha 2 into delta theta. Similarly, theta into R2 that's equals to I can write theta into R2 means L into 1 plus alpha 1 into delta theta. This is our equation number 1. This is our equation number 2. So if I did equation 2 minus equation 1 means RHS will be equivalent to what? RHS is equivalent to theta of R2 minus R1. Theta R2 minus theta R1 means I can write theta of R2 minus R1. Okay, that's equals to here L is taken out. 1 plus alpha 1 into delta theta minus 1 plus alpha 2 into delta theta means what can I write here? This one now, this one gets cancelled. Finally, I'll get alpha 1 minus alpha 2 into delta theta of L. I can write. Got it? This is okay. So this is it. So then what they're asking means average radius. So what is an average radius? For example, this is average radius R. So then what is this means? So this is nothing but average length that is equal to initial length. I can write here. From this what can I write again? Angle theta is equals to I can write this R L divided by R I can write. So therefore L divided by R into what is this R2 minus R1 stands for? R2 minus R1 means this is nothing but R2 minus R1. That R2 minus R1 is nothing but thickness of this thing. Then I can write thickness T that's equals to alpha 1 minus alpha 2 into delta theta of L. This L gets cancelled. So then T by R equal to this one. No? Then R is equal what can I write? R is equals to T divided by alpha 1 minus alpha 2 into delta theta. So this is nothing but the average radius R. T value they have given the thickness 2 centimeter. Alpha 1, alpha 2 they have given, and the temperature difference also they have given. So substitute if not getting, let us see tomorrow. Okay.
Tilt the board little upwards so it's not visible.
by